Today my presentation topic is extended coordination and augmented max pressure for a distributed single coordination at connected intersections. The presenter is Jiangchen, and the authors are Jiangchen, Dr. Peng Fan, and Professor Qiu. The supervisor is Professor Qiu. First is the background. As shown on the left side, we have more and more connected vehicles and intelligent vehicles on the road side. They together with the connected infrastructure form our connected intersections with connectivity and intelligence. However, there are some potential concerns in this connected intersection control. First is the inconsistency between the macro and micro-based single control. Then we need unified adaptive single control that is valid for both levels. This means it should be valid for both single vehicles and traffic flow also. Third, it is a hierarchical system complexity, how the coordination might integrate with adaptive sync control, how to deal with the spatial coupling, and how to integrate offset split simultaneous. Last is penetration concern of the connected vehicles in the early stage. Today we are focusing on single coordination by coordination diagram method. Then it is a literature review. First, we do a quick review of the PCD and its variants as shown here. They can divide it into two groups by data sources, which are using loop detectors and CV data. The first category is using loop detectors. Original PCD is widely distributed to characterize the coordination performances starting from 2008. Then when considering the vehicle speeds, it is the color PCD. Then when considering the multiple days integrations, it is aggregated PCD. For second category using CV lag or CV based data, the first one is a detector free PCD using the CV based arrays. Then it is a CV based PCD to utilize the CV data to obtain quantitative evaluation of the smooth progression along a corridor. Then it is by cycling coordination to deal with the platoon coordination. Then the TSS diagram is used to handle the singulars and trajectories at the same time. Also, rivals on the coordination is proposed to handle two insertions for their offset adjustment performances recently. Then, from a larger perspective, we investigate their characteristics. First, we start from the PCD perspective. Overall, current PCD is only used for one phase for consecutive periods. How to aggregate multiple PCD still next. Imprecise, the MP inspired is brand new. From performance index research perspective, most measures are active measures. Usually, there are temporal aggregations like the LQR in the UTC strategy. For multi-objective research, the elective spatial weights might be introduced like the total travel time, but most of them are focused on centralized control. In summary, distributed inspired coordination should be investigated. Thus, we propose a new distributed single coordination at connective intersections in this paper. A coordination augmented max pressure is developed here. The left side shows the differential PCD for each cycle. First, at each cycle, the PCD is calculated for both upstream and downstream. Then they are subtracted from each other, then obtain the differential PCD for one phase within the next cycle. Then a variant is built. The one cycle is replaced with each time step t. Moreover, the instant PCD is defined as the Q divided by the total vehicle numbers. Then we obtain the instant differential PCD for one phase for each time step. Then we test our method in 23W within the active test bed as shown in the left figure. Several comprehensive scenarios are included here for the validation. The target insertion is while downstream 23W insertion as shown in the red figures. The upstream shows the geometry, the downstream shows the phase setting. Simulation is conducted by Shomo simulating and Python script. Then simulation results are presented here. For For network demand level are used here. Three strategies are compiled, which actually control MP instant PCD. The red figure shows quantitative results. As shown in the table, the results demonstrate the efficiency of the proposed method for single control for all three performances. For most cases, then we draw figures for a deep investigation for both average speed and time nodes, as shown here. We can find the following result. First, for both MP and instant DCP are better than actuated control for large demands. Second, the proposed instant DPCD is better than the MP in the same network input. Last, the phase setting should be improved. Last, we go to conclusion and future work. In this paper, an extended coordination-augmented MP is proposed for a distributed synchronization. The proposed method is better than MP and actually control in the same network. Moreover, results demonstrate the efficiency with more and different inputs. In the future, other variants will be investigated. More comprehensive scenarios, including more insertions and field tests, will be conducted. Last, MEC and 5G impacts will be investigated, as shown in the last figure. Thank you for your listening. If you have any questions, please ask me.